Hi, my name is Avile, and I run a company called Avile Labs LLC in Seattle, where we do interesting stuff with data science and Python. And in this multi-part series, we learn how to package our Python 3.x projects. By the end of this series, we'll learn how to distribute our Python project as either a library or an executable. We'll learn how to add non-code files to the package. So these would be things like CSV files or image files that are in our project and that we need in our installed package on our target machine. And we'll also learn how to do some post-install steps. So for example, you might want to set up your package as a cron job on the target machine. And we'll learn exactly just how to do that. But in this part, we will focus on how to distribute our project as either a library or an executable. And all the code that you will be using can be found in my Bitbucket repo. It's publicly accessible. And I learned all of this stuff from the packaging.python.org website, which has some pretty extensive documentation on a lot of the features that we'll cover here. Okay, without further ado, let us go ahead and clone the code that I have in this repository. So you can find all of this code in bitbucket.org, Avile sample-app. And you saw this link in the slide that we saw previously. Now, once the code has been cloned, we go inside the project directory, which is sample-app, and then check out step-1-start branch. And before we dive into the code, let us look at the structure of our directory. So you can see that we have the project directory, which was sample-app. And then inside that, you have one root package, which is sample_app. And that root package has three sub-packages. The first one, very creatively, is named package_1. The second one is called package_2. And the third one is the test package, which has all our unit tests, as you can see by the test_module names. And each of our sub-packages has one single module. So we have pack_1 and pack_2. And sort of our main program is in this module, sample-app, which is inside the root package. So let us now examine the code. So in package_1 package, we will look at the code of pack1 module. So as you can see, it is a pretty straightforward class with just one public method called do, which returns a string. And similarly, pack_2 module is also a pretty straightforward class. It has one public method called process, but this method prints out this particular sentence in color. So it prints it out in orange color, and which is where we see our dependency on the colored package. And then it returns a number. And our main function just instantiates the two packages and then calls the methods. So pretty straightforward. Now our goal is to zip this project up into an installable, which we will then install onto an Ubuntu VM that I have running in Azure. So let's check out our Ubuntu VM. So I SSH into it. You can see that it is a public IP. And if I now say pip show colored, that's not installed here. Pip show sample app, that's not installed here either. And by the end of this tutorial, we will have both of these packages installed. All you do is go to the top level project directory. Mind you, not inside your root package. But in the top level package, you create a file. Conventionally, it's called setup. You can call it anything you want, though. And in this, all you do is call this one function called setup. And you import it from the setup tools package that comes standard. And you need to call setup with a bunch of parameters. The packages parameter, we are telling setup which packages and their corresponding sub-packages to include. Now we could have named each and every package in our project, so sample app, package 1, package 2, test, and whatnot. But we can use this handy function call that is also provided by setup tools. Right? So we imported it from setup tools. It's called find packages. And that will recursively just list all our packages from wherever the setup.py is located. So it will include our sample underscore app and package underscore 1 and so on. And that's it. This is all we need to package our code. Now, while we are developing, it might be a good idea to run and install this package locally. So how do we do that? So notice that I'm back on my local machine. I'm not on the VM anymore. So I say sudo pip3 install. Now, all of you who are listening and watching this video has used pip3 install. But instead of supplying a package name, we will say -e and dot, which says make use of this current directory. Let's actually go to another directory and try to use our packages. So we say from sample underscore app. Now, remember, even though the name of my package is sample-app, the name of my installable, rather, is sample-app, the top level package is called sample underscore app. Package 2.pack2 import pack2. Right, so we had to give the entire name, which was sample underscore app, package underscore 2, pack underscore 2, and the name of the class. And if you notice, that's what we did here as well. And then let's instantiate the class and run it. Woohoo! It works. But we are not very happy with this kind of an import. We want it to be easier for our users to import our package. So the way to fix that is we go to our sample underscore app init.py. So now, if we start IPython again, we should just be able to say from sample underscore app import pack2. As usual, we run the method and woohoo, it works. Now you might decide that you actually do not need the test package in your target machine, or it should not be part of your installable. So the way to tell find packages to exclude some package is to provide its name. So exclude accepts an array of all the package names, fully qualified package names that it should ignore. And our package name is sample underscore app.test. One final thing. Remember, our project depends on the colored third-party package. And the way we specify third-party dependencies is by supplying the install requires parameter, which also accepts an array of third-party packages. We just have one, so we supply that. And that is it. This is all we had to do to create our package. Now let us go ahead and actually generate the installable. Now remember, the last time we did the pip3 install -e dot, it created this egginfo directory. Now you want to get rid of it. Otherwise it can lead to some pretty bizarre behavior. Okay, so now we should be good. And in order to generate the installable, all we do is call setup.py with a single command line parameter called sdist. And that generates, it'll generate the egginfo again, which we can ignore. It generates this dist directory, which has our installable, the tar.gz. So we're done. Let's see, just for kicks and giggles, what is inside this installable. So let's open it up. So as you can see, it has our top level package, and we excluded our test package. So it just has package 1 and package 2 and a bunch of other ancillary information that it needs to install this package onto the target machine. So let's now go and do that. Let's copy this tar.gz file over to our VM in Azure. Okay, so now it has been copied over. Let us SSH into this box. Installed packages from PyPy, where we just give the name of the package and pip goes and downloads it from PyPy. In our case, because we have it locally, we can just give it the tar.gz name and it will work exactly the same way. There we go. So now you see that it actually also installed colored, because remember we didn't have it. Go ahead and see that. Yep, there it is. And look at all the information that we gave. The version is here. The short description is here. Our home page, author, email, license, and whatnot. And this is the colored information. Again, we have all sorts of information here. The version, summary, author, their emails, and whatnot. So let's now use our package. Say from sample app. Import pack2. Yay, our library works on a remote machine. So what we did just now was authored a Python project, authored the setup file, generated the library locally. We generated the install.gz, the sample app.gz, and we deployed it onto our production VM, installed it there, and used it. Now in this last part of the tutorial, we will see how to deploy our sample app project as an executable, as opposed to a library that we have seen so far. To do that, let us look at the sample_app.py, which we have pretty much ignored up until now. We can see that it has a main method, a main function rather. It's instantiating pack1 and pack2, and it's just calling these two methods. And this method doesn't print out anything, it just returns a string. This method returns a number, but it prints out the string. This is pack2 that we've been seeing so far. So running this program should give us that same output. Let's go ahead and do that now. Sure enough, this works. And what we want is for our users to be able to just run this project as an application. And setup makes it super easy for us to do that. So as usual, we specify another function parameter called entry points, which takes in a hash with a key called console scripts, whose value is an array. And here we have a decision to make. What do we want to call our app? Let's call it SAP. Then we need to specify the fully qualified function name that we want to invoke. So that is sample app colon main. Right? So sample app for our top level package, sample app for our module name, and we have the main function inside of this module. And that is it. Let us now generate our installable. But before we do that, remember to get rid of the egg info. Oh, and before we run this, let us go ahead and bump the version number of our package to 2, right? So we made it 2.0.0. Let's run this now. And sure enough, we see that our dist folder has 2.0.0 tar.gz. And as usual, let's examine what's inside there. It's pretty much the same as 1.0.0. But let's see how it looks on our target machine. So let's copy it there. Okay, so here it is. Now before we do a pip install, let's remove the earlier version just so we have a clean slate. Okay. And now if we just run this command from the command line, there you have it. We have our project's main method main function being executed. And if you're curious as to what this is, what SAP is, so we see it is in user local bin. Let's figure out what kind of file it is. It's a Python script. Let's open it up. Sure enough, this looks like some Python code that was auto-generated for us, which executes our main function. So what we covered today was how to author setup.py to generate a library or an executable as an installable, how to deploy this installable to a remote machine, install it there, and run it. I hope you had as much fun watching this tutorial as I had making it, and I hope to see you again in part 2.